Good morning, boys and girls, or good afternoon, depending on what time you're watching this video. Today is September 28th, 2020, and today in science, we will be discussing the difference between elements and compounds and mixtures, okay? So just a quick recap. We discussed that matter can be classified into two categories, pure substances and mixtures. And remember that pure substances can be either elements or compounds. And then mixtures could be either heterogeneous or homogeneous or homogeneous. So let us continue discussing this topic. Our objective for today is to identify the difference between elements and compounds and mixtures. And at the end of this lesson, you will be able to answer 10 questions, at least 8 of them out of 10 correctly. Okay. So, RTEK is matter and energy. The student knows the difference between elements and compounds. The student is expected to know that an element is a pure substance represented by a chemical symbol. Okay, so in order to begin talking about that, last time we focused a little more on mixtures. And so today I want to focus more on the compounds and elements part. So we're going to begin this lesson by discussing atoms. Atoms are the smallest unit of an element that maintain the properties of that element. Okay, so everything is composed of atoms, and we have to understand how matter is classified. Okay, so the substances you encounter every day can be classified into two major classes of matter, pure substances and mixtures. Atoms are basic building blocks for all two types of matter. Pure substances and mixtures differ in the way that atoms are combined. So here, take a moment to pause this video and go ahead, and if you click on this green word that says atoms, there is an atoms video on BrainPop that I would like for you to watch if you are watching this on your own. And if not, when we are in class, we will be looking at it and discussing it together. Okay. So now that we've learned a little bit about atoms, the next thing we have to look at is an element. Okay. An element is made up of one or more of the same kind of atom chemically combined. So let me read that again. One or more of the same kind. It is important to remember that, okay? So an element is made up of one or more of the same kind of atom chemically combined. It is a pure substance that cannot be separated into similar substances by physical or chemical means. So, boys and girls, we discussed a little bit about elements, and we said that elements are found on the periodic table. And all elements are represented by a symbol. Okay, all elements have a symbol, and the periodic table is broken apart depending on the category or the type of element that it is, and we will be discussing that further during the week. But today's focus is, again, elements, compounds, and mixtures. Okay, so we want to make sure we understand that an element is the same kind of an atom. Okay, and just a reminder, matter can be classified into two major classes of matter. Pure substances, which can be elements and compounds, and mixtures, which are heterogeneous or homogeneous. Okay, a compound. Okay, so element and compound are both pure substances, but remember we said an element is of the same kind of atom. And a compound is made up of different kinds of atoms chemically combined. It's a pure substance composed of two or more different elements joined by chemical bonds. Compounds have different properties from the elements that make them up. So real quick, I know I said elements and they're found on the periodic table, but an example would be like gold or hydrogen or oxygen. All of those are elements, and they're represented by a symbol, and they're just made up of one kind. But then when we discuss compounds, That's going to be like your oxygen and 2 hydrogens, which is H2O and can make water. Or it could be NaCl, which is table salt. So a compound has a chemical formula because it's 2 elements together that create something else. Okay, compounds have different properties from the elements that make them up. Okay, so a compound is made up of different kinds of atoms chemically combined, pure substance composed of 2 or more different elements joined by chemical bonds. And then we move on to mixtures. A mixture contains a variety of elements and compounds that are not chemically combined. Okay, that's important to remember, that are not chemically combined with each other. Are a combination of 2 or more pure substances that are not chemically combined. So mixtures are a little more messy. It's when they contain more stuff, more ingredients, but they are not chemically combined. Okay. If you take a minute and pause this video and you take a look and explore this Brain Pop video, it explains further compounds and mixtures. We are going to be looking at some examples today, and we are going to determine if those examples are either elements, compounds, and mixtures. Okay, we also are going to do another lesson that goes further into substances. You will be doing that in your groups or individually, depending on during the time that you have logged on into class. Okay, in order to better understand pure substances, we are going to go over this lesson in Nearpod, and it discusses different substances. What are pure substances? By the end of this lesson, you will be able to explain what pure substances are and distinguish between elements and compounds. And so remember, boys and girls, there are over 100 elements are known to exist, okay? Each element has a place in an arrangement called the periodic table of the elements. The periodic table is a useful tool that can help you to identify elements that have similar properties. Metals, nonmetals, and metalloids occupy different regions of the periodic table. Metals start at the left and make up most of the elements in the periodic table. Nonmetals are the right and are often shaded with a color different from that of metals. Not surprisingly, the metalloids lie between the metals and nonmetals. In many instances, you can even predict which elements combine with others to form compounds based on their position in the periodic table. So again, we will be looking more into metals, nonmetals, and metalloids later on during the week. Our focus again is elements, compounds, pure substances, and mixtures. Okay, so in today's lesson, you'll learn about pure substances. You will explore a 3D model of a pure substance. Watch a video to learn about different types of these substances and distinguish between pure substances. You will discuss why scientists classify matter in this way. Okay, in chemistry, one way that matter is classified according to whether it's a pure substance or a mixture. Sodium is an example of a pure substance, while salt water is an example of a mixture. So we saw salt and water on Friday and learned that it was a mixture. And we learned that the water is the solvent and the salt is the water is the salt. Okay, so what do you already know about the differences between a pure substance and a mixture? So you could take this moment to pause the video and discuss that if you have a partner. And if not, just think about what is the difference between, what do you know already, pure substance and a mixture. Okay, let's take a moment to look at this model of gold. And then while you're looking at it, think, What did you notice about this model? Why do you think it would be classified or considered a pure substance? What did you notice about that model? And if you need to go back and take a look at it and think a little bit about this question, you may also click on this and it will bring you back to that video. And when you're ready to exit, just hit the X. Okay. And then in addition to gold, what other elements can you think of? List as many as you can. So what elements can you think of, boys and girls? And then take a moment to list them here. Okay, so we know that gold is an element and it is a pure substance, and we know gold is found on the periodic table. I asked you previously to list as many elements as you could, if there was any that you knew of. And so let's go ahead and stop and think. So you learned that the element gold is an example of a pure substance. Do you think all elements are pure substances? Why or why not? Take a moment and think about this question, and then go ahead and put your answer. Okay. Elements versus compounds. So pure substances are either elements or compounds. On the next slide, you will watch a video that explains the difference between elements and compounds. After you complete watching the video, you'll complete a short quiz to demonstrate your understanding of the key points. So it's very important to pay attention. Okay, so compounds, how can they be classified? So you are surrounded by compounds. Compounds make up the food you eat, the school supplies you use, and the clothes you wear. Even you. There are so many compounds that it would be very difficult to list or describe them all. Fortunately, these compounds can be grouped into a few basic categories by their properties. So compounds have properties by their pH balance, as organic or inorganic, by their role in their body. So again, compounds can be classified by their properties. Okay. I'm not sure if my microphone cut off a bit ago, boys and girls. I hope that, so I'm going to repeat myself just a little bit, make sure that it did not cut off. So I hope you enjoyed that previous lesson on pure substances, and it gave you a better idea of what it is or what they are. And now our focus is mixtures. Okay, so what are mixtures? Imagine that you roll out some dough and tomato sauce and sprinkle some cheese on top. Then you add green peppers, mushrooms, and pepperoni. What have you just made? That's right, a pizza. Of course, but that's not all. You have also created a mixture. A mixture is a combination of two or more substances that are combined physically but not chemically. Again, they're combined physically but not chemically. When two or more materials are put together, they form a mixture. If they do not change chemically to form a new substance, for example, cheese and tomato sauce do not react when they are combined to make a pizza. They keep their original identities and properties. So a pizza is a mixture. Mixtures are made up of more than one type of particle. Unlike elements and compounds, mixtures are not pure substances. Mixtures contain more than one type of substance. Each substance in a mixture has the same chemical makeup it had before the mixture formed. Unlike pure substances, mixtures do not have definite properties. Granite from different parts of the world could contain different minerals in different ratios. Pizzas made by different people could have different toppings. Mixtures do not have defined properties because they do not have a defined chemical makeup. Okay, so going back to the pizza example. You don't like mushrooms on your pizza? What can you... Okay, so let's go back to the example of pizza. So let's say you don't like mushroom on your pizza. All you have to do is pick them off. The change is a physical change of the mixture because the identities of the substances do not change. But not all mixtures are as easy to separate as pizza. You cannot just pick salt out of water, out of a salt-water mixture. You would have to heat up the water, make sure it evaporates, and then the salt will be left behind. Another way to separate could be by using a magnet, for example, if you were trying to separate a mixture of aluminum nails and iron nails. So remember, mixtures are also classified into two categories: homogeneous, and heterogeneous. I hope you enjoyed this lesson, boys and girls, and on Wednesday we will continue discussing physical and chemical changes. I will see you Wednesday.